ml.
So answer is what? ml square by 3. That's all. So very simple one. See here why the limits is 0 to L, everybody. Here the axis of rotation is passing at the one end of the rod. It's not at the center of axis. So if it is the COM, center of mass means then the limits will be L by 2 to minus L by 2. But here the axis of rotation is passing at the end. So then means in the sense of the limits is from 0 to L directly. So you can substitute it and you can make sure it is, that's all over. Anything doubt you can ask me. Any doubt, please let me know. You clear?
No. Yes, sir.
Try. You unless you try, you cannot be. Adam Aswida, I don't know. Aswida not joined. Murali not joined. I don't know what people this. Is Narayan completed?
Yes, sir.
Yeah, do it. So next one we'll solve. Next one is mass of a ring. Okay. So sorry, moment of inertia of a ring will solve and then we'll add up. Write it. Moment of inertia of a ring. Calculate the moment of inertia of a ring whose mass is m and radius is r. Now ring I am speaking. So can you guess? R is always remains constant or where is r? If you know that, that is enough. Yes, please. R is remains constant or where is? Everybody? Hey, ring means what is that? It is having
Constant.
center. Any point you can go. R is always remains what?
Constant.
Constant.
That point, if you remember, is okay. See, in a rod, what is happening? From the center, is it all the distances are same? If I am going different differences, is it all the distances are same? Please respond. No. Do you understanding? So that is why R is not constant. But here it's the same. That X is not constant. But here from the center, any point is same. Question you write. Calculate the moment of inertia of a ring whose mass is m and r radius is r about an axis through COM, center of mass, and is perpendicular to plane of ring. Perpendicular to plane of ring. All of you observe. So axis of rotation is passing through the COM, but it is perpendicular to what? Plane of ring. So now if I kept a ring on a base, it is exerting two axes. One is y-axis, another one is x-axis. So now axis of rotation is passing perpendicularly to the plane. Means in the sense of it is passing how? Which axis? Everybody. Exactly z-axis. Am I right or wrong? Please respond, Ra. So if I consider
Yes,
the
sir.
plane, so this is the plane means in the sense of you can see we'll be having three axes. So plane, if I consider exactly perpendicular, imagine that your notebook you take and you put your hole in the middle. So that is what is perpendicular to plane. You take your notebooks. I cannot show you. I'll so okay. So just a minute. I'll send you the video of 2 seconds. So you all can notice it. All of you. So if I consider that, what do you mean by plane? So our notebook is our plane. Am I right or wrong, everybody? Our notebook is our plane. Correct, Amma? So now the center of mass is passing how? The center of mass. If I consider this is a notebook, is my plane. So now if you notice it, the center of mass is the axis of rotation is passing perpendicularly to the plane of the ring. So I'll consider this is the ring. If I consider, then it is acting perpendicularly to the plane of the ring. So that is what I send you the video. Just all of you go through that. So we can continue. All of you have a glance. So check it, everyone. So that is what. So the ring is placed on the paper or in front of your bench. Just have a glance, everybody. So now perpendicularly means it is going like this. Here two-dimensional, so I cannot show you. So this is what is called as perpendicular to the plane. Am I right or wrong, everybody? So let me take the axis of rotation is x and x. All of you verify it. Everybody, imagine you make one hole to your textbook, a notebook. That is what is perpendicular to COM. Correct, Amma? Please respond, everybody. All of you?
Yes, sir.
That is what. So have you watched the video? So let me take a ring now. So the center of mass. So this is a plane actually. So perpendicularly the axis of rotation is passing. Perpendicularly the axis of rotation is passing. Now, so from the center, if I go, I will select any particular part. Here I not draw ring properly, you can take. So the mass of this one is, let me consider dm. But from the center of mass, what is the distance? Which is always what, everybody? R. If I take mass here, the particular part is dm. And from here also, what is that, everybody? R. If I take this particular part, if I take this particular part, if I take this particular part, if I take particular part, dm mass, dm mass, dm mass, and dm mass. So from the center, R is always what, everybody? From the center, R is always what? Remains? Please respond. Remains constant. So I want to find the now what is the moment of inertia of a ring about an axis. About an axis through what? Axis of rotation is passing through what, guys? COM, center of mass, which is perpendicularly to the plane. Have you watched the video, brothers? Understood? Yes?
Yes,
So
sir.
that is which is equals to, I will take, so di is equals to integration of, you can apply integration of di is equals to dm into r square. Understanding? So that is what is r square. I can take any point, r is remains. So we all know integration of di is I, so I is equals to, now tell me, in a circular ring is from the center, r value is in all the directions, r is remains what, everybody? R values remains what, guys? All of you?
Constant.
R is remains constant. So means in the sense of, so this R square never goes under integration, constant, integration of dm. So can you tell me integration of dm what will gives? Integration of dx will gives you x. Integration of dy will gives you.
M.
So integration of dm will gives you what, everybody? M. So the moment of inertia through center of mass of an axis of rotation, so which is I is equals to r square into m. So this is the formula for moment of inertia. Moment of inertia is equals to on a ring. So m r square. Please write it. This is the formula for that one. Any doubt? Anybody can ask me. I hope you all understand. Any doubt? Please let me know. Clear, everybody? All of you? So ring, moment of inertia of a ring. So the ring is also will consider as a one dimensional, so that you can see. But what is the rod and the ring? What is the difference between the rod and the ring? Everybody, rod we have been taken with x is not remains constant, but here x is r is remains what? Everybody, r is remains. Yes, please. R is remains what? Constant. Understanding? So in rod, the x distance, this and this is not equal. If I take this and this is also, they are not equal. From the center of mass. From the center of mass, it is not equal. Or if I consider a rod where axis of rotation is passing at the one end. If I take this particle, let me take that is x1. If I take this particle, if I take that is x2. If I take this particle, I will take it as a x3. So is it all x1? X1 and x3 is equal or not equal? Everybody. X1 and x2 and x3 is equal or not equal? All of you. Is not equal. But if I take the ring, so what will happen? From the center of mass, always x only it is. If I take any direction, always it is x. X means r, radius. So what will happen? The moment of inertia of that one, which is equals to m r square. That is what you have to remember. Anybody having doubt, you can ask. Clear, everybody? I hope everybody clear. All of you? Yes, please.
Yes.
Yeah. So this is what is about it. So kindly go through that and solve this one, and we'll continue. Clear, everybody? Okay, guys. So this is what is about the rod and as well as ring. Then tomorrow we'll see the disc and as well as triangular lamina and as well as cylinder. So that is all two-dimensional it is. So then from there we'll continue in the tomorrow's class. With this I'll stop. I hope you all understand today's class very clearly. Anybody having any doubt, please let me know. Are you all understand? Everybody?
Yes.
Yeah. So this is what about it. So please go through that and solve. when you are getting time, please kindly wake up and solve related to that. Then only you can do anything. I'm expecting everybody will wake up morning and follow. So please make it happen. That is what is expecting from you all. Okay. Strictly follow. You must wake up like 10th class, how you are responding. Report me. Then only I can know correct whether you are doing or not. That's what you understand it. Okay. Thank you, everybody. We'll meet in tomorrow class.